Okay, welcome to Unit 8. This is the first section, 8.1, Introduction to Transformations and Absolute Values. Okay, so for this unit we'll be focusing on functions, lots of different types of functions. So we've already learned about quadratics, and a lot of these problems, when you'll be looking at those, will be in vertex form. We'll also learn about absolute value functions, also piecewise functions, and exponential functions. Okay, and we'll compare them, and also we will, in 8.2, we will figure out how to do the average rate of change, so basically the slope. And that will be our unit. So here we got in 8.1, into to transformations and absolute values. So we'll focus to start is just transformations, and then we'll do absolute value functions as well. Okay, so we'll try and do this as best as I can. Transformations are things like if you have this is your parent graph, okay, and we're going to compare all other graphs based on that parent graph. So if we had a graph that was over here, and it was a parabola, it's the same shape, but just a different location, this would be shifted, okay, and we'll talk about how parabolas can be shifted. We can also look at graphs that have been, say, if a equaled 2, and it would be stretched, okay, something like that. I guess there's a good graph of that right here, okay? So where this is like your parent graph, okay, it goes over 1, up 1. That's your parent graph, okay? And then if a is greater than 1, like for example this one, if you go over 1, up to where it hits again, we get a equals 2 for this graph, and that means it's been stretched, so a is greater than 1, so it's stretched. And here, since a, you go over 1 and it comes up to 1/2, a equals 1/2, it is compressed. All right, and then we'll also be talking about reflection over the x-axis. So here we have a equals 1, you go over 1, up 1, that's our a value is 1, and here for beneath it we have go over 1, down 1, so here we'd have a equals -1. So this is called reflection over the x-axis. All right, and those are the three, basically the three things. These two are basically the same, 2, 3, and 4. Shifting right or left versus up or down. They're both shifts. Okay, so those are the three main things that we'll be doing. There are other things that you can do, different types of transformations, but we will not be talking about that at this time. Okay, so again, let's just go over these. Reflected over the x-axis, that is when a is negative. Okay, so we're looking at the sign of a. Okay, the sign is negative. Okay, so you could even write that if you wanted to. Either way, a is negative, or the sign of a is negative. Sign of a is negative. Okay. Stretching and compressing. Stretch is when the absolute value of a is greater than 1. Also, you could also say it's just the number, not the sign. So if we don't look at the sign, if it's greater than 1, then it is stretched by a factor of whatever number that is. Okay, and if the absolute value of a is less than 1, then it's compressed by a factor of whatever number that is. Okay, and then shifting right or left, okay, based on h and k. So h and k will tell you if it goes up, if x is positive, sorry, if k is positive. If k is positive, then it goes up, and if k is negative, then it goes down, which is kind of intuitive. Okay, so k is positive, it goes up, k is negative, goes down. And it's the same with h. So if h is positive, it goes right, and if h is negative, it goes down or left. Okay, so let's just look at some examples, see if we can figure this out. It says, without graphing, describe the transformations of each parabola. Okay, so that's what we got. We got a parabola. It's in vertex form. We want to find out, first off, is it reflected over the x-axis? Okay, and when it's reflected, like we look at these two problems right here that we looked at, reflected when a is negative, because you could also say that it's concave down. If it's concave down, then it is reflected over the x-axis. So here we look at this, the sign in front of a, since it's positive, it doesn't have a negative, then we would say that it's not reflected over the x-axis. And you don't need to write that down because we didn't change the parent graph. Okay, second, is it stretch, compress, or neither? Okay, we would only look at the number, which is 0.5. And since that's less than 1, we would say it's let me fix that. It is vertically compressed by a factor of 1/2 or 0.5. Okay, so I've had people ask, like, do you have to write it down vertically compressed with a factor of 1/2? Why can't you just do it more simple? Well, the thing is if you leave some of this stuff out, then it doesn't mean what it says or what you're trying to say. So it's very important that we include vertically compressed so that it's not compressed in a different direction. And it's all affected, the whole thing is being affected by the factor of 1/2. I could probably let it slide as long as you wrote vertically compressed by 1/2. If you didn't want to put a factor of, I would probably still allow that. But you definitely need to have vertically compressed or vertically stretched and the number. Okay. So basically, we want to be able to write this down in words that you could come up and graph or come up with the equation with enough words to be able to do that. Okay? All right, so next we've got vertically compressed by a factor of 1/2. Next we got a shifts. Do we have any shifts? Okay, so we look at that and we would see, is it shifting up or down? Well, what is h? Because that does, or sorry, up or down is your k. Let me do the other one first. So is it going left or right? Okay, and what is h? So if you want, you can write down what your vertex is, because that is your h and k. So here your vertex, here is 2, 3. And remember that whenever you take something out of a parenthesis, like this, it switches its sign. That's why it's 2. And if you look at the original equation for vertex form, there's a negative h in there already. So that's why when we take it out, we need to switch that sign. Okay? So hopefully that makes sense. So we shifted, we'll shift, since h is a positive 2, we'll go right 2. And since since k is a positive 3, right here, then we can say that it is shifted up 3. Okay, so let's do some of these others. I mean, you don't need to write down your vertex as long as you realize that when you shift, this -2 will make it go right 2. Okay, so it's like the opposite of what you would think. But K's are just how it looks, what you would think. All right, so here, let's look at the next one. Is it rotated, or I mean, is it reflected over the x-axis? Yes, because A is negative. That will make it be concave down. So we would say it's reflected over the x-axis. And again, you need to write all of this information because it could be reflected over a different axis or a different line. Okay, so make sure you write that down. Is it stretched or compressed? Well, here A, the absolute value of A is just 1. So it's not stretched or compressed, so we don't even need to write that down. And then shifts. Is it shifted? Here, this is our H. That does our X directions. So is it going left or right? Okay, so if we pulled this out, it would switch the sign, so it would be -5. So if you wanted to write down your vertex, that'd be -5, 0. So it would be shifted left 5, and it wouldn't go up or down, okay? Because K is 0, and that's all you would need to write is reflected over the x-axis and shifted left 5. Okay, last one. Okay, is it reflected over the x-axis? Yes, because it's negative. So we would write the same thing right here. Okay, and you'll say the same thing all the time. It will always be reflected over the x-axis, and we won't be reflecting over anything else at this point. Okay, so next we want to look at the number. We don't want to look at the sign. So since it's 2, 2 is greater than 1. That means it's being vertically stretched by a factor of 2. Okay, and then the shifts. Is it shifting up or down? This tells us if it's up or down. Since it's negative, it goes down 9, and this will tell us whether it's going left or right. So since it's negative, and when you pull this out, it will switch its sign, so it will be a +12, which means it goes right 12. Right? So I just would like to kind of talk about, let's do. I just like to go over one of these equations step by step. So here what we're doing is, let's look at this one up here. It might not fit in the graph totally, but we'll see how this works. Okay, so our parent graph, I'm going to graph our parent graph. This is y equals x squared. And we are going to transform it to look like this equation. All right, step 1, we reflect it over the x-axis. So we reflect it over like this. That's the reflection that we just did. Okay. Next, it's not stretched or compressed, but we are shifted. So next, we shift it 5 to the left. So that would be here, here, and here for our points. And you can't see it all the way out, obviously. But that would be your final equation. So we flipped it over, and then we shifted it 5. Okay? So those are like the steps of what we did to be able to get this equation that is given. Okay? So you'll always reflect first, then you'll stretch or compress, and then you'll shift wherever it goes. Okay? 2 questions real quick. Can a function be stretched and compressed at the same time? Nope, it cannot. You can't have an a value that is both greater than 1 and also one that is less than 1. You can't have a number that could do both of those things. So you would just say nope. Okay, can a function be stretched and reflected? You bet you can. Okay, so that's what we did right here in this example. Okay, it was vertically stretched and it was also reflected. Okay, and I wrote it right here. Okay, reflected. Okay, all right, so hopefully you're okay with that. Just remember, one more time, if the sign of A, so for example, this one, this is your sign. If it's negative, it's reflected. If it's not, you don't need to write anything. If you look at the number, that will tell us if it is stretched or compressed. If it's neither, if it's 1, then you don't need to do anything. Okay, and then these numbers, this tells us left or right, and it's going to be the opposite sign when you pull it out. And then K, you keep your sign. Okay, so that will bring it, the negative will make it go down. So negative is down, positive is up, and then for left or right, left is negative, and for H, if H is negative, then it goes left, and if H is positive, it goes right. Okay, so H here is just 12. It's not negative 12. Because when you pull it out, it switches the sign. Okay, all right, you got that. Sorry. Okay, next. It says graph each function and state the domain and range using interval notation and inequality notation. And we'll go over both of those. Okay, so here we can graph. Our vertex here is -4, because remember when you take something out, it switches its sign, and then -3. So this would be our vertex. And then A equals -2, so we'll use our growth pattern. 1 times A is -2, so we'll go over 1, down 2, both sides. And then 3A, that will give us 3 times -2, which is -6. You'll go over 1, down 6. Okay, and that doesn't really fit on the graph. That's okay. We're really doing this so that we can talk more about domain and range. Okay, domain is all x possible x values based on your equation, okay, or the graph. So every time you'll go over 1 and then down 2, over 1, down 6, over 1, down whatever, okay? So every time, this will keep going over and over to infinity, okay? And same as the other side. So there we have x values for our domain. We'll go from -infinity to infinity, okay? And for all of the situations, they will always go from infinity to infinity. We'll have other functions that maybe perhaps we cannot do that, but for all the ones we're doing, the domains will go from -infinity to infinity. And then we also need to be able to write this in an inequality notation. Okay, inequalities are things like, let me come over here, inequalities are like a less than or equal to, greater than, or greater than and equal to. Okay, so those are inequalities. Basically, we're saying if we set like 3 is less than 5, okay, they're not equal, they're inequalities, they're not equal, okay? All right, if that makes sense. All right, so here you could rewrite it as all x values between -infinity to infinity, okay? Or -infinity is less than x, which is less than infinity. So that was how you would, this is how you would write it in inequality notation. Okay, and then range Looks like I'm back to Christmas colors. Range is all possible y values. So it's like the same thing. Range is all possible y values. So here, the highest y value here is at -3, and it keeps continuing down to -infinity. Okay, but when you write things down for like range, you need to write it from the lowest value to the highest. So here you'd go from -infinity to -3. Okay, if you wanted to write it as an inequality, kind of running out of space. Let me just clear this out. Okay, to write it as an inequality, you would say y is less than or equal to -3. So all y values that are less than or equal to 3 are on this graph if you went on to infinity. Okay. All right, we'll go over this one really quick. So again, vertex is 1, -2. When you take it out, it switches the sign. 1, -2, and then our growth pattern, A is 1, so you'll go over 1, up 1, over 1, up 3, over 1, up 5. So it's a odd growth pattern, 1A, 3A, 5A. And then you do it with the other side as well. Okay, so just a quick review on graphing parabolas, or quadratics. Okay, but really what we're focusing on is the domain and range. So here, domain is going to be the same. You write it as -infinity to infinity. And I think I missed something over here. I did. Okay, so whenever it's a range, -3 is included on your graph, so that's included. If you plugged in -3 into this equation, or I guess you couldn't. I'm saying if you plugged in -4 in your equation, you would get -3, and that's a value. Okay, there's no x value that you could plug in that would give you a y value of say 3. Okay, so that's why it's not on this. All right, so again, we'll write this as both forms less than x, less than infinity. And you don't ever do less than or equal to, because infinity is not a number. Okay, you can't, it just isn't a number. Okay, so you can't have it be on a line. Okay, and then range, here you would write it as its lowest value, which here would be -2, and we do a bracket because it's included, and it goes all the way to infinity. Okay, and we do a parenthesis since it's not included. And then you can also write this as all y values greater than or equal to -2. So that would be an inequality notation. All right, so next let's do absolute value functions. So as you notice, or may not notice, that this is our absolute value function, and it has the same types of constants that we have in our equations, a, h, and k. If you go back to it in vertex form, we have a, h, and k. And they're all kind of the same location and everything. The only difference is we have an absolute value instead of a parenthesis, and it's not squared. Okay, so a, h, and k will do the exact same transformations. Okay, so let's talk a little bit more about absolute value functions. So if we made this table and we wanted to find out x, say x equals -3, -2, -1, 0, 1, 2, and 3, if you plug these values in for x and you take the absolute value makes any number be positive. So if you plug in a -3, you'll get a +3. Plug in a -2, you get a +2, and so forth. you plug in a positive, it also keeps it as a positive. It never switches it to be a negative. Okay? So if you graph that, it would look something like this. You kind of messed that up a little bit, but you get the point. Okay? So that is what an absolute value function looks like. And this, what you're looking here is, in this equation, this is the parent graph. So just like we did with the parent graph right here, this is the parent graph for an absolute value function. So we'll be reflecting it over the x-axis, we'll be stretching or compressing based on what A is, and then we'll shift it around based on our h and k. Okay, so one thing I noticed that these should not be here. These aren't squared. Okay, it wouldn't really make a difference though if you didn't notice that, because it would be the same transformations. Okay, and that's the same as this problem D. Okay, so here we go. First thing we want to see is it reflected over the x-axis? So let's look at a different color. It is. So here is where we would reflect it over the x-axis. It would look something like this. Okay, kind of messed that up a little bit, right? More like that. Okay, so we reflected it over the x-axis. So we'd write it here, would say reflected over the x-axis. Okay, next thing is we want to, and that tells us that it's negative. Since it's negative, that's what we get. Okay, next we're going to look at, let's do a different color, orange. Let's look at 2. We don't look at the sign. Okay, so 2, that means since A is greater than 1, 2 is greater than 1, that means that it's stretched. Vertically stretched by a factor of 2. Okay, we don't look at the sign, we just look at the number. Okay, so here we're stretching it. What we're going to do to stretch is it's going to go more like this. Okay, and A, when we're graphing, A gives us, we use it as a slope instead of a growth pattern. So when you do that, you will do the slope, like here, our slope here is -2. So we'll go rise over run, we'll go down 2 over 1, down 2 over 1, down 2 over 1. And we'll always do that on the right side. After we have the right side of our vertex, then we will mirror it over the other side. Okay? And then the final thing is, one more color, let's do purple. Okay, so next is shifts. Okay, so we'd look at that, we'd look at H is 0, and here we have K equals 3. So H, that's our left and right, so it doesn't move left or right, but K is a positive 3, so it goes up 3. So we will move our graph up 3, so here's where it started, 1, 2, 3, and then it has the same slope. Okay. So this is what the graph would look like. But you can do this really quick without going through all of these steps. Okay, so purple is your final graph based on all of this information. Okay, without that. Okay, all right, so let's do it again, but without graphing, because it says without graphing. Let's look at it. Is A negative? No, that means it's not reflected over the x-axis. Next we look at the number. of A. Since it's 1/2, we would say it is vertically compressed by a factor of 1/2. Okay, and then we look at the shifts. Okay, is it shifted left or right based on H? So here, H, when you take it out, it's -5, so that means it goes left 5. And then K is a +2, so it goes up 2. Right? And then the last one, is it reflected over the x-axis? Yes. So we'd write that down here. And then we'd say, is it stretched or compressed? No, because the absolute value of A is -1. The absolute value of A equals 1, which is not less than or equal to, so it's not stretched or compressed. So we wouldn't need to write anything. And then we'd do our shift. We would look at our H. H is 6, so it goes right 6, and it goes down 2. Okay. All right. Last thing we have here is we need to graph and state the domain and range. Okay. Here I don't ask you, or at least for this note, for our notes, you don't need to write it for either, but I'll probably write it in inequality notation. Okay, so here, graph, it's the same thing. So we'd want to find out what is our vertex. Okay, this would be like +0 for our K. So we'd write it as -4, 0. So that would be our vertex. And then we would want to, instead of using a growth pattern for A, here A equals -1, we're going to use it as your slope. So slope is going to be -1/1 for like your rise over run. Okay, so you will go down 1/1, down 1/1, so forth. Okay, and then you only do that on the right side. You're going to mirror over the axis of symmetry. So it will go like this. Okay, so all of these absolute value functions will be these or V's upside down. Okay, they'll never be like just a line, a straight line, because that would be mx plus b. So this is kind of different. All right, so hopefully that's not too bad. And then if you wanted to write it in words, how to explain it, you would say it is mirrored, or not mirrored, what's the word? Reflected. Reflected over the x-axis. It's not asking you to do that. I just wanted to make sure you have lots of examples. Next we say, is it stretched or compressed? So since A equals 1, or the absolute value of A is 1, then it's not stretched or compressed. And then for the shift, it would be shifted left 4. And that's what it's done. It's been like the original graph. If it was, it would be something like this. And then we after that, we reflect it over, and then we would shift it left 4. Okay? All right, so I'm not going to go over all those steps like that. We're just going to, oh yeah, the other thing it asked is the domain and range. So the domain, let me just clear this out a little bit. Domain and range, domain, it will always be the same. So I'm going to write it in this inequality notation. And then the range, that would be our domain. Range is going to be all y values less than or equal to 0. Okay? Next one, our vertex here is going to be 1, negative 2, 1, negative 2, and then your slope is negative 1 over 1. So it has the same as the other one we did. Okay, and then we mirror over the axis of symmetry. Okay. And just the thing, there's a couple of people in my classes that we did this first part, and they're like, oh, this is super easy. I'm just going to just start doing my homework. And then they got to this part, and they had to ask questions because they weren't paying attention. So in class, if you would please pay attention and don't start doing your homework until we've covered all of the information. That would be much appreciated. Okay, that way you don't get lost, and I don't have to tell it over and over again. Okay. Okay, next one. Here, vertex 1, negative 3, 1, negative 3, and then we have a negative slope, negative 2 over 1. So you'll go down 2 over 1, down 2 over 1, and you'll do it on the other side too. Okay? And then domain and range. Domain is the same, so it would be negative infinity less than x less than infinity. And then range would be all y values less than or equal to negative 3. Okay? Last one, just remember I crossed that out, so don't get confused. It's not a parabola. Our vertex is negative 4, negative 2, negative 4, negative 2, and then it's not, our slope is 3 over 1. So we'll go up 3 over 1, up 3 over 1, like this, and then you just mirror over the other side. Okay, and there you go. And then here would have domain would be the same, and range is going to be all y values greater than or equal to negative 2. All right, so if you have any questions, please let me know. Just going to look at the homework really quick, make sure that we understand how to do these. So for example, these ones already, you just need to write down, like if it's reflected, write that down. If it is stretched or compressed, we'll write something down. If it's shifted, so you'll just want to write down the same things we did kind of in the notes, but based on looking at A and H and K. Okay, and then here these are the opposite ones for like number 6. You'll do the opposite. So they will give you the information, like for example here, a quadratic function. Quadratic function is y equals ax minus h squared plus k. And so using this information, we will come up with an equation. So this is transformed 3 units to the right and 5 units down. So that tells us our h and k. And if it doesn't say anything about a, if it says it doesn't say that it was reflected, or if it says it doesn't stretched or compressed, then we know that a is just 1. Okay, and you'll run and do some of those. Here you'll need to graph. Make sure you'll just do it by the vertex, and then you'll use, since it's a quadratic, you're going to be using it as the a value as your growth pattern. Okay, and you'll be able to graph, and then make sure you state the domain and range. Okay, make me proud and do it both ways. Okay, and then just have graphing, and okay, and then here we start doing with absolute values. So these are absolute value functions, and you'll do the same thing. You're going to describe it based on what A is, H, and K. Make sure when you take something out, it changes its sign. Right? And then here you'll want to graph it as well. So you'll find your vertex, and you'll use your slope instead of, will be the same value as your A value as your slope. Okay, and you'll be able to graph those, and they'll look something like these at the bottom. But here you just need to find the equation of the function shown in the graph. So you'll want to write the equation based on that graph. Okay, and I think that will cover it. All right, thanks for watching. Please, what is it? Subscribe and something, I don't know, okay? And if you have those updates so that when I get a new one, that'd be nice. If you wanted that, you can make it so you can get a notification when I put a new post on, okay?